Hopefully not.
You
what?
Hey, Demetria! Sorry, I forgot.
Okay, that's okay when you're on time. You can do that, you know. When you're late, I expect you to walk in quietly, hang your head in shame, and just sit down.
You want me to walk back in and do it?
No, I'll give you. All right, so we're doing the reverse of what we did the other day. So this would be like if you were actually a chemist, you took some substance and you started figuring out what percentage was this, what percentage was that. You want to be able to figure out what the formula is. That's what we're doing today. So I'm going to give you the mass of the sample and the percent composition, and you're going to figure out what the formula is. So I'll give you steps again, and that should make it easier. So let's do step 1, find the mass of each element.
Bless you.
Bless you. Oh, sorry, Travis. I thought it was on the same. I know why.
So here this would be like, I give you the mass of the sample. I say it's 75% carbon, so you do 0.75 times that. That gives you the mass of carbon. If I say it's 25% hydrogen, you do 0.25 times the mass of the sample. That's the mass of the hydrogen, and so on. All right. Next, we find the number of moles of each element. So that's pretty straightforward. Once you found the mass, you use this equation. Number of moles equals mass divided by molar mass. We've used this 1,000 times. So this will be whatever mass you calculated number 1. This will be off the periodic table. Number 3. Write the formula with the number of moles as subscripts. So whatever numbers you calculated in number 2, you're going to pretend that those are the little numbers in the formula. So let's say I did number 2, and I said, okay, I got 10 moles of carbon, then I'll write C10. And let's say I got 40 moles of hydrogen, I'll write H40. And for now, that'll be my formula until I simplify it. So that's what you're doing. And then for the last step, find the simplest whole number ratio. So there's a couple different ways to do this. The book on page 310 gives one way to do this. The easiest way, I think, is just to divide by the greatest common factor. And it's one of those things where you really just have to understand ratios. I mean, if you don't understand that a 100 to 200 ratio is the same as a 1 to 2 ratio, there's just no way for me to explain that to you. You know, if you see 10 to 40, you should automatically think that's a 1 to 4 ratio, right? If I divide both of these by 10, I'll get C1H4. So that's what you got to get. You're just simplifying the ratio to the smallest numbers so it's easier to understand. So for this one, you look at these and you're like, well, 10 is a factor for both these numbers. That should be obvious. So divide both numbers by 10. If you came out with a formula like H4O2, well, what's the greatest common factor? 2. 2. So you divide them both by 2, and you get H2O. Okay, that looks more familiar. That looks like water. So you're just trying to simplify the ratio of these numbers to whatever's the smallest you can come up with. Does that make sense?
Yep.
All right, let's do an example problem. Does everybody have, how much you guys got rid of?
I got up to 3.
Up to 3, so I'll erase up to 2. Okay, so let's say the example 1, a 216 gram sample is found to be 83.3% carbon and 16.7% hydrogen. Find the formula. Erasing the rest of the steps. All right, so what are we going to do first?
Find the mass of each element.
Right, so we're going to find the mass of carbon and find the mass of hydrogen. So mass of carbon, it's going to be, so we're going to take the mass of the whole sample, 216, times whatever fraction of that is carbon, which is 83.3%. But percents are useless, right? We have to make it into a decimal, which is what it really is. So how do we do that? Yeah, you divide by 100 and turn it into 0.833. And this is like for every situation where you ever use percents in real life, you can never do a calculation with a percent. You always have to divide it by 100 and turn it into the decimal that it really was. Okay, so 216 times 0.833, what's that come out to?
179.928.
179.9, that's good enough. And that'll be grams. All right, let's do the other one, the hydrogen.
So you're not taking the mass from there?
We're going to use that later. So far, I'm just finding out the mass of carbon in this sample. We'll come to that in a second. All right, this one is 216 times
16.7.
right, so we're going to make that 0.167.
Didn't you just divide it?
You mean do like times 16.7 divided by 100?
No, like 216 just divided by 16.7.
No.
That comes.
That would give you about 12 and some change.
That comes out to 36.072.
Okay, 0.0, so 36.
407.
All right, 0.1. Want to be exact. Okay, so let's, that's step 1. We found the mass of each one. That's the mass of carbon, that's the mass of hydrogen. Step 2 says what?
Step 2 says find the number of moles in each element.
Okay, number of moles in each element. So number of moles of carbon, remember, number of moles is mass divided by molar mass. So it's going to be the mass of the sample that I have, 179.9, divided by the molar mass of carbon, which is what? 12. Right? And we get that from the periodic table. You look at carbon, and under it says number 12. That's what right there. All right, so 179.9 divided by 12, what's that come out to? 14.99. Okay, now you know that normally I hate rounding, and usually I tell you the decimal place doesn't matter when you're rounding, but in this case our goal is to get to whole numbers, and since we know our measurements aren't exact, when you get to this step, if you get a number that's really close to a whole number, round it to a whole number. So we're just going to put 15. So let's say roughly equals 15. Okay. Normally we would never do this, but this is the one time, special exception. All right, number of moles of hydrogen. So we're going to do 36.1, it should say grams, right? 36.1 grams divided by, what's the mass of hydrogen? 1 gram. So that's 36.1 moles. And so here again, it's about 36. We're going to round it to 36. Okay, so we have the number of moles of both things. We have carbon and we have hydrogen. What's step 3? Write them as subscripts. So you're going to write a formula for this substance using those numbers. So you're going to call it C15H36. So I'm just taking this 15 moles of carbon, 36 moles of hydrogen, and I'm making a formula. Okay, so this is good, except for we want to simplify this. And so what's the greatest common factor of these two numbers? 3, right? We can divide them both by 3 and still get a whole number. Almost. All right, so let's divide both numbers by 3. What's 15 divided by 3? 5. So C5, what's it, 36 over 3? 12. So C5H12. That's our formula. That's it.
That's done.
That's done. Should I do another one?
No.
All right. That's pretty decisive there.